Okay, we're here at the Grow House. My name is Sam Squillace. We're here with Colorado Aquaponics looking at an aquaponics growing system for real-world apps biology. All right, so tell us who you are and what you do here.
I'm JD Sawyer. I'm the owner of Colorado Aquaponics, and this is Flourish Farm here. And here at the farm, we raise fish and plants together in a natural ecosystem, providing food to the community and local markets and restaurants.
And what is the difference between hydroponics and aquaponics?
Sure. Hydroponics, you're growing plants in soilless media, but you're typically doing that with either an organic nutrient solution or some synthetic type of nutrient solution. In aquaponics, we actually raise fish. And the fish, through their waste stream, are actually providing nutrients to the plants. So it's more of a natural ecosystem where one organism is providing and helping another organism. We don't discharge any water. We continue to recirculate that water. And that's important because we can grow a tremendous amount of food with a fraction of the water that you would otherwise use in traditional forms of soil-based agriculture or even in hydroponics.
What kind of sciences have you learned as you've gone through this process?
Understanding fish and their requirements, water quality, things that are toxic to fish, not toxic to fish, oxygen, flow rates, all these things that are necessary for the health of the fish, because we have to have healthy fish in order for this to work. And then certainly understanding the plant side of the house. What do plants need to thrive? Sunlight and nutrients and ventilation, airflow, all these different things. And then within that, there's the bacteria. That's the part we don't see as much, but it's critically important to this process too. And understanding their role in making sure that the fish waste can actually be converted to usable nutrients to grow plants.
JD, you just mentioned 3 different organisms. You mentioned plants, fish, and bacteria. And in biology, we talk about something called symbiotic relationships, right? Where each organism in the relationship provides a benefit for another organism. So how does that work in aquaponics?
Sure. Well, how about I take you around and show you how that works?
That sounds great. Okay, so JD, we're here looking at these different fish tanks. Tell me, what is going on here?
Right, so in this system here, we have fish. We're raising actually tilapia in this particular tank here. And the tilapia provide nutrients to the plants through their waste. So we regularly feed these fish, and they're doing their thing, pooping and producing urine. And that actually produces ammonia, among other things. And it's the ammonia that bacteria are actually converting into usable nitrogen or nitrate nitrogen for the plants. We do that particularly in this tank here. This is called a mineralization tank. And we capture a lot of that waste that comes through from the fish tank. And you can see all of these brushes here. These brushes actually help to capture and collect a lot of that waste and creates a home and a habitat for bacteria to help break that down into the trace minerals and elements that plants need.
The plant roots in the aquaponics system are actually just floating right in the water. Why is it that that doesn't create rot for the plant roots, or why don't the plants take up too much water? Why isn't that an issue?
Right, so in this particular case, we actually provide a great deal of oxygen, dissolved oxygen. We have little air stones that bubble up oxygen, and so if the roots are able to uptake oxygen, we don't have those types of issues that you mentioned. This is a little raft board here of Bibb lettuce. And you can actually see nice white roots is what you're looking for. If we were sending a lot of fish waste in here, these could get all brown and mucky, which would be a problem for the plants, and they would have difficulty getting the oxygen and the nutrients they need. But these have nice white healthy roots here, and they're getting a nice mix of the perfect temperature of the water, a nice balance of nutrients 24/7. And in that respect too, we get tremendous growth rates in aquaponics because they're getting nutrients all the time.
JD, there's been sort of a science focus in our interview today. I've been wondering about how biology relates to this, but what other school subjects might we be surprised that you would need to have a basis in to be successful in aquaponics?
Yeah, you know, there's a lot of different subject matters that are all integrated into an aquaponics system. Certainly the STEM subjects, science, technology, engineering. We do a lot of math here. There's defined relationships between the amount of feed and nutrient availability to plants that we mathematically figure out. From an engineering standpoint, we're dealing with water flow. So we've got hydraulic engineering, we've got structural engineering. You could go well beyond into the culinary arts, nutrition, economics, business subjects to really understand all of these things interrelate, particularly when you're managing a farm as a business, to understand how all these things work together in one farm. I can't think of any subject that's not somehow tied in to aquaponics in one way or another.
There's this old saying that you might have heard of, and it goes, if you give a man a fish, he'll eat for a day. But if you teach a man to fish, he'll eat for the rest of his life. Do you think we should change that saying so that we should teach a man to do aquaponics?
Yeah, absolutely. I mean, this is what it's all about. We are teaching people how to raise their own fish and feed their families, feed their communities. This is how we're going to change food production and make our planet more sustainable. So I love it.
Well, JD, I've really had a pleasure talking with you. Thank you so much for doing the interview today.
Likewise, it was a pleasure. Thank you.
Subscribe! Come on, push the button.
You know you want to.
Do it.